Hello and welcome to my science tutorials. In today's video, we want to look at how to solve quadratic equation by using the method of completing the square. Alright, so in our previous tutorial, we did look at how to use the method of factorization to solve quadratic equations. Now, it's not always the case that you have an expression or a quadratic equation that you can easily factorize. Now, in the absence of you being able to factorize a quadratic equation, which other ways can you use to solve the quadratic equation? That's what we are about to look at. So the other ways, so first of all, we can use the method of factorization to solve a quadratic equation. But in case we cannot factorize the equation, what other way can we use to find the factors of the equation? So one of them we can use is what we call the graphical method, and this involves us drawing a graph and using the graph to find the values of x. Or another method is completing the square. That is what we'll be looking at in today's video. So completing the square, and this is a very easy, super easy method, but a lot of students find it very difficult. So I'll be taking my time to explain step by step everything you need to do. Once you follow them, you'll never get the method of completing the square wrong ever again. Alright, so the last way of solving a quadratic equation is by using what we call the quadratic formula. Okay, quadratic formula, or some people call it the almighty formula. But then this formula, you realize that it was derived from the quadratic expression using the method of completing the square, and we'll be looking at that in our next video. So we already look at how to solve quadratic equation by the method of factorization. Today we'll be looking at how to solve quadratic equation using the completing of squares, and then in our subsequent videos we'll be using the quadratic formula and hopefully the graphical method in the next subsequent tutorial. Right, so let's look at how to solve quadratic equations using the method of completing the square. Right, so we have the expression x squared minus 6x plus 2 is equal to 0, and we have to solve this expression by the method of completing the square. Now the first thing you need to do, and always make sure you remember this, the first thing you always have to do is to make sure that the coefficient of the x squared term over here is 1. Always make sure it is 1. So assuming I have 2x squared minus 6x plus 4 is equal to 0, always make sure you divide by 2, divide 2 by the coefficient of x to make sure x squared is standing alone. Always make sure that the coefficient of x squared term is 1 before you go ahead and try to solve any problem on the method of completing the square. So now that we have this problem and we don't need to do anything because the coefficient of the x squared term is already 1, let's look at the next thing we need to do. So we need to rearrange this equation. So we write x squared minus 6x, then we send a constant to the other side of the equal to sign, so it becomes minus 2. Okay, so the next thing we need to do after rearranging is we add to both sides half square the coefficient of x, the coefficient of x. Alright, so let me explain using this example. So what it means by that is, first of all, what is the coefficient of x here? It means that is negative 6. So I find half of negative 6. Half of negative 6 will give me negative 3. Okay, so the expression is, or the sentence is saying half square. So now that I found the half, I need to square it. So negative 3 square is 9. So this is half squared. So I need to add it to both sides of the equation. So I have x squared minus 6x plus 9 is equal to negative 2 plus 9. Alright, now the reason why we need to make the coefficient of the x squared term 1 and add half square coefficient of x is because we want to get a perfect square on the left side of the equation. Now this is an expression that we call a perfect square. Perfect square in the sense that I can rewrite this as x minus 3 all squared. if I expand this expression, I'm going to get what I have at the top over here. So let's look at how it works. It's either you rewrite this as 3 squared, then you take the x, the 3 together and square it, or you identify that it's a perfect square and then you do it like that. So this is a perfect square. Let's look at that. So we have x minus 3 squared. So this is equal to x minus 3, x minus 3. So let me multiply, expand, and let's see whether it's correct. So we have x into bracket x minus 3, then minus 3 into bracket x minus 3. So x multiplied by x will give me x squared. This will give me negative 3x. This will give me another negative 3x, and this will give me positive 9. So this is equal to x squared minus 3x minus 3x will give me minus 6x plus 9. So we can see that the expression x minus 3 squared is equal to this expression we have over here, which is the same that we have over here. So I can rewrite this whole expression as this in this sense because it is a perfect square. Alright, so from here I've rewritten this as a perfect square, and this is equal to negative 2 plus 9 will give me positive 7. Alright, so from here all I need to do is to make sure that I find the value of x. So I can do that by first of all getting rid of the square over here. So I find the root of both sides. So the root of x minus 3 squared is equal to, now if you're taking the root of any number, you add plus or minus, then the root of 7. So this will cancel this. So we have x minus 3 is equal to plus or minus the root of 7. So from here we can proceed to solve for the values of x. So let me get rid of this. Okay, so from here I rewrite my expression as x is equal to, I send the negative 3 to the other side of the equal to sign, it becomes positive 3 plus or minus the root of 7. So my x values will be x1 is equal to positive 3, then I take one of the signs plus root 7, or positive 3 minus root 7. Okay, so my x will be equal to positive 3 plus root 7 will give me 5.646, or positive 3 minus root 7 will give me 0.354. So these two values, s is equal to 0.354 or 5.646, becomes the root of this equation, or the answers that will make this equation equal to 0. Alright, so let's have a look at another equation so that we actually understand furthermore what we mean by the method of completing the square. So I have the expression x squared plus 5x plus 4 is equal to 0 using the completing the square method. Alright, so as always, the first thing I need to do is to make sure the coefficient of my x squared term is 1, and which is the case over here. The next step is for me to rearrange this equation by writing x squared plus 5x is equal to negative 4. I sent the positive 4 to the other side of the equal to sign. Alright, so over here I add half square coefficient of x, okay, that is, I add to both sides the coefficient of x. So that will be equal to half of 5 will be 5 on 2, then I square it. So this is the half squared, the coefficient of x. So it means my expression becomes x squared plus 5x plus 5 on 2 squared is equal to negative 4 plus 5 on 2 squared. Alright, so this side of the expression again is also a perfect square. So you take the x over here, x, then plus what we have over here, which is 5 on 2 squared. Okay, so if you expand this expression, you are going to get what you have at the top over here. So you always take where the s square, when you're solving the method of completing square, you have the s square term, and then the value that you added, if if you take them and then square it together, it will give you the expansion you have at the top over here. So we have this as a perfect square written as this is equal to negative 4 plus, now over here 5 on 2 will give me 2.5, and if I square it, that will give me 6.25 over here. So I still have my expression x plus 5 on 2 squared is equal to negative 4 plus 6.25 will give me 2.25. Right, so the first thing I need to do is to get rid of my square over here. So I do that by taking the root of both sides. So the root of x plus 5 on 2 squared will be equal to plus or minus the root of 2.25. So this cancels this. I have x plus 5 on 2 is equal to plus or minus the root of 2.25 is equal to 1.5. Right, so from here the next thing I need to do is to rearrange this equation. So I write x is equal to, if I send the 5 on 2 to the other side of the equal to sign, it becomes negative 5 on 2 plus or minus 1.5. So my x values are equal to negative 5 on 2 plus 1.5, or negative 5 on 2 minus 1.5. So this will be equal to negative 5 on 2 plus 1.5 will give me negative 1, or negative 5 on 2 minus 1.5 will give me negative 4. So my answers, or the root of the equation x squared plus 5x plus 4 is equal to negative 1 or negative 4. Okay, now you can also use the method of factorization to factorize this expression, and you will still get negative 1, negative 4. Right, so let's have a look at another example. So we have to solve the following quadratic equation. So we have a question: solve the following quadratic equations using the method of completing the square. Okay, so we have we have 2s squared plus 4x minus 6 is equal to 0. Plus 6 is equal to 0. And then we have I, that is 3s squared minus 18x minus 27 is equal to 0. All right, so let's have a look at this. Okay, so the question doesn't end there. It says leaving your answer in set form. So leaving your answers in set form. Okay, so let's write down our solution. So the first expression we have is 2s squared plus 4x plus 6 is equal to 0. As always, the first thing you need to do is to make sure that the coefficient of the x squared term is 1. So I do that by dividing both sides by 2. Everything here by 2. So I divide by 2, by 2, by 2. So this cancels this. So I have x squared plus 4 on 2 will give me 2x plus 6 on 2 will give me 3 is equal to 0 on 2 will give me 0. So this becomes my new expression. Right, so from here I need to rewrite this expression. So I have x squared plus 2x is equal to negative 3. I send the 3 to the other side of the equal to sign. Now I add half square coefficient of x. So half of 2 will be 1. So that is half of 2 will be equal to 1. So I square 1. So I add it to this both sides. So I have x squared plus 2x plus 1 squared is equal to minus 3 plus 1 squared. So this side, as usual, is a perfect square, so it means I can write x plus 1 all squared. So I have x plus 1 all squared is equal to minus 3 plus 1 squared is still 1. So I have this over here. So I have x plus 1 squared is equal to negative 3 plus 1 will give me negative 2. So from here, I have to get rid of the square sign over here so that I can find my x. So I find the root of x plus 1 squared is equal to plus or minus the root of negative 2. This will cancel this, so I have x plus 1 is equal to plus or minus the root of 2. So x is equal to, I send a positive 1 to the other side, so it becomes minus 1 plus or minus the root of negative 2. Now note that root negative 2 will give you a complex number. Because it will give us a complex number, we do not want to solve it, because if you enter it into your calculator, it will be giving you an expression with an I inside, which is a complex number. That is why the question is demanding that we leave our answer in a set form. So my values of x are minus 1 plus the root of negative 2, or x is equal to minus 1 minus the root of negative 2. So this becomes my answer for this particular expression. Alright, so let's go ahead and find the solution for the second problem. So let me quickly erase. Alright, so the second expression is 3x squared minus 18x minus 27 is equal to 0. As usual, I need to make sure that the s squared term is standing alone, so I divide both sides by 3. So I have this cancels this, so I have x squared minus 18 on 3 is going to give me 6x. That minus 27 on 3 will give me a 9 is equal to, this will give me 0. Alright, so from here the next thing I need to do is to rearrange this equation. I write s squared minus 6s is equal to positive 9. I send the 9 to the other side of the equal to sign. So from here I add half square the coefficient of x. So half square the coefficient of x means that I have here half of negative 6, so half of negative 6 will give me a negative 3, and then I square that. So I have here s squared minus 6x plus into bracket negative 3 squared is equal to 9 plus into bracket negative 3 squared over here. So I can, this will give me a perfect square. Either I write this as 9 or like this, it's still going to give me a perfect square. So 3 minus 3 all squared. So I have x, this x over here, then minus this 3 minus 3 squared. If I expand this, I'm going to get this expression is equal to 9 plus negative 3 squared will give me 9. So I have over here x minus 3 squared is equal to 9 plus 9 will give me 18. So as usual, I need to get rid of the square by introducing my root, but if I introduce it over here, I need to add plus or minus. So it means this cancel this, and I have x minus 3 is equal to plus or minus the root of 18. Right, so from here I can write my x is equal to, I send the 3 to the other side of the equal to sign, it becomes positive. So I have 3 plus or minus the root of 18. So the values of x for this particular expression, or this equation, this equation is equal to positive 3 plus root 18, or positive 3 minus root 18. Okay, so this becomes the answer for my second expression, and as you can see, I'm leaving them in set form since they have root sign inside of them. So thank you so much for watching. This is how we use the method of completing the square to find the factors or the roots of a quadratic equation. So up next we'll be looking at how to use the quadratic formula to solve quadratic equation. So thank you once again for watching, and I'll see you in the next video. Bye bye.